Hello everyone, welcome back. Today, we will continue discussing about the DNS, the domain name system, and the service which provides DNS is Route 53 in AWS. Yesterday we already saw Route 53. We need to create something called as hosted zone, right? Just a quick recap, and then we'll get started. So we need a hosted zone to be created. inside that hosted zone Inside the hosted zone, you could create your DNS entries, right? Now these hosted zones are of two types. One is private and the other one is public, right? So to have a public hosted zone, a valid public hosted zone, you should have a domain registered for yourself, number one. And it could be abc.com or example.com or something that has to be first registered with you, and then only you would be able to create your Route 53 in a public hosted zone. Right? So then only it would function as a public DNS provider. Else it's not gonna work. You still would be able to create it, but you would not be able to replicate or get the DNS on your laptop remotely. That's not gonna happen. Right? We would be testing the entire stuff on private hosted zones, and we will be creating a lot of DNS entries. So the DNS entries, there are type of DNS entries. So this type A, which is nothing but name to an IPv4 address. Then we have AAAA. I will not be creating it, but it's just a name to an IPv6 IP address. We have something called as a CNAME, which we can also be creating. And then we have something called as alias, which would also might work, right? So these are all the things, and if time permits, we might also be able to test it out or test out something, right? So let's actually see if we can do that. So let's jump into the AWS console. Let's also plan to do some testing. So what I'll do is I'll launch two EC2 instances. One is where we would be creating our my server. I just increase the name count to 2, and we'll rename one of the server to something else, right? So I'm going with a T3 micro, and I hope I am in the right region. So let's go to US East 1, where I am going to create my web server. So what am I going to do? We are going to host a simple website, simple HTML website, and then try to see how it goes. I'll keep this in public subnet 1A. Security groups. Do we have any security group which is for SSH? No. Okay. Let's create a new security group. I'll call it as my SSH SG. What I also want to do is add a security group that allows HTTP traffic, and I would allow it from the entire world. Right? So source type would be anywhere, and I'm going to allow it from the entire world, and that should be good, right? So this is how I launch my EC2 instances. Now, very quickly, okay, I did only create one. That's not good. Still fine, right? So what I'll do is let's collect on this EC2 instance. By the time I open and trace my keys, I believe we should be able to SSH it. So that way, so second L is SSH. I key user at their IP address, which is this. Most probably it starts working by now, and I am logged into my machine. The first thing that I do is a yum update, and the next thing that we would be doing is install httpd dot service. I'll do a hyphen by so that it doesn't ask me for a yes or no. Now the HTTPD service is enabled, right? So systemctl enable HTTPD dot service. Then we will do a systemctl. Before restarting, let's actually go inside the directory where .html. There should be nothing inside it, so we'll create an index.html and hello, we might be testing some on Route 53. Okay, this is what I have, and I click save this. Now, what I'm going to do is system cdn restart http dot service. All good. So if you do a curl local host, you should be getting hello. We might be testing some DNS on Route 53. This is what we get. Should be fine. Now let's actually come to the crux of it, that is Route 53. So, do I have anything? So, number one point, Route 53 is a global service, right? It's not region dependent or anything. It is a global service. And if you don't have any hosted zones, so this is the page that we will get into. If you want to actually have all the options, it's always there, hidden. Even if you could click on get started or you could click on hosted zones, it's totally up to you. But because we know that we have to create a hosted zone, so I'll go create a hosted zone for ourselves. I clicked on create a hosted zone, and here you can get your example.com. So I call it as my.com, right? And the description is mine, and I'm going to create a private hosted zone. That means it is not going to be available outside of AWS, right? Here you need to select the VPC in which you want to attach it and the VPC. So that's primary number one. And let's say you have another region and another VPC, you can provide that VPC also, right? There's no blocker over there, and you can create a hosted zone like this, right? As soon as you create a hosted zone, there are two records that primarily come out. The first record is NS. NS is nothing but the name server record. Now, what is actually happening is, even though AWS is keeping, you are creating all the DNS entries over here, right? So these name servers, so these DNS entries, whatever you go ahead and create, right? These will actually be saved on these servers, right? This is the actual server where the DNS would be located, right? So this is name server, and if you see, this is AWS DNS, right? So these are name servers of the AWS DNS itself. It's not some other name servers, right? Similarly, if you go for a GoDaddy.com or if you have a hosted zone in GoDaddy, right? You would also get some access to DNS, and even there, you would see that the DNS is there would be some name server where the DNS is actually stored. SOA is site of authority. So this is again a default entry that gets created. So there are two entries that get created automatically when you create a hosted zone. So the first thing that I do is I'll create my DNS entry. So I'll call it as web01 web01.my.com, right? And the IP address that I would be providing is it's totally up to us. You could either provide a public IP address or an internal private IP address. I'll go ahead with the private IP address. This is there. TTL is something that I'll explain in a second. Let's first click on create a record. So the record that we created is web01 my.com. The type of record is A, which was somewhere over here, which we didn't do a drop down. So it was type A record. Then we provide the value, and then we click on create a record. Once this is done, what we will do is copy this, and what we can do is if you do a curl instead of localhost, if you do this, you might be getting the same output. That is, hello, we might be testing DNS. That means this is working. Now, how do you test it extensively? You could actually have it on a different EC2 instance. So you could create a different EC2 instance. My test machine. I don't care what the spelling is. Keep it over here. And if you want, you can keep it in a different subnet. So I'll give it in a public subnet 1B, and everything else remains the same. And I feel on the systems. So I have this EC2 instance also ready. Let's see what the IP address is, and then we'll try to SSH into that. So what you can do is launch another git bash window and cd into the location where the keys are ssh hyphen I my key ec2 hyphen user at the rate and the IP address. This it's asking me to access certificates, which is fine. Now this server is not going to have anything, right? So what I'll do is curl, that is web01.my.com. The domain is horrible. See, if you see, this is thinking a bit, which is not good. But then we should be able to get some output very soon. Now, any idea why this is not working? Let's troubleshoot really quick. What is it doing? Is it timing out? So, for every timeout issue, what could be the possible reason? A firewall sitting somewhere could be a possibility, right? So, let's actually look at that. Now, firewall, so network ACL, so we have kept it in the public subnet, so that means the public ACL is responsible for anything and everything. And we are not allowing port number 80 to go out, right? So what I would be doing is I would be creating a rule number 600. Hope everyone remembers these things. I'm just doing it on the fly, not explaining to you every detail of it. I would keep it as 10.18.0.0/16, which is our CIDR range. I click on save changes. And the inbound role is anyways allowing port number 80 to come in. So that means that should now work. Okay, it's working, right? So that was the that was the ACL rule which was not allowing it. If you're still in doubt, please give it a try and then we'll see what it is. Let's say I want to create a different DNS entry. Where is my DNS? I'll go back. Let's say I want to create a different DNS entry, and this time I want to call it as not web01, but I'll call it as demo.my.com, right? Demo.my.com, and I want to create a CNAME. So when I create a CNAME, I need to create it for an existing record itself. So that is web01.my.com, right? And you can create a record. What is a CNAME? So CNAME is a name to name mapping. So web0my.com is actually having an A record, which is this, right? Which is pointing to this IP. So what I've done is I pointed demo to web01my.com. That means demo should also load the same website which web01 has been loading. Clear? Making sense? Now what I could do is for testing purpose, right? We could have another website over here. So how do you do that? Sudo su yum update y Then you could do, I'm also installing HTTPD over here and we'll put some other website over it, right? So that is install HTTP, that is yes. I go into CD where html vi index dot html. I'll just say, right, done. We need to do a system ctl enable http service. Then I need to do something called a system cdn restart http dot service. If you remember one thing, we are missing one thing on the test machine. If you go to the security group, we didn't allow port number 80 to come in, right? So make sure that you're allowing port number 80 to come in. Now, that could be from within the VPC CIDR also. You don't have to necessarily provide a 0.0.0 thing, right? So you could provide it from within the VPC, that should still work. So what you could do is now, in order to test it out, you need to create a record, right? Now, because this is the first time we're creating a record, right? So uh, I'll call it as test.my.com, and here I need to provide the IP address of my EC2 instance. Which one? The test machine. So the test machine's IP address is 10.18.1.29, right? So this is created. Now what you could do is curl test.my.com should give you hello, right? So the DNS is very, very, very fast is what we see. What happened to this, right? So if you do a curl test.my.com, so that should work, should give you hello, right? So I'm testing it from both the places. Now, if you want, you can get another C name or something, and that should still work for you folks, right? Now, let me quickly show you the different type of records that we have, right? So you have CNAME, which you've already seen. AAA, we already know that it's for IPv6. We have something called as MX record, that is for mail servers. So remember we did SES yesterday, right? And in SES, there was a domain-based verification that we didn't do. So if you went for the domain-based verification, what would happen is you will get some MX records and some TXT records to be created, right? And then you have to update those records into a public DNS entry or a domain where your or DNS where your domain is registered. So once you create those, that is when it will start working. Okay, so these are the two records that we have. Then again, there are a lot of other records, PTR, SRE, SPF, right? So I personally haven't used many of these. We only rely on a C name, and occasionally, if you're working with SES and domains like this, maybe you would be interacting with MX and TXT records, right? So these are the different type of records that we. Now for alias records, right? If you select this option of alias, right? So this is not going to provide you with an option to type out anything, but basically what happens is you can select an Amazon resource that you want to tag that with. So let's say I want to tag uh, network.my.com with a network load balancer. So what I can do is I can select a network load balancer of my liking. Now the only problem is I don't have a network load balancer, right? So we don't have any network load balancer in Northwest Virginia one to actually pinpoint it. But this is how it is going to go. So we have network.my.com and you could actually point that thing to it and you can click on create record and it will create an alias record. So alias records actually point to the direct resource in AWS. You might be having a question. Does it point to an EC2 instance also? The answer is no. It doesn't point to an EC2 instance, right? It only points to load balancers. Then you have some CloudFront distributions and some other things. EC2 instance is something which is not counting. Okay, so That's about the alias record. It's not complete. Let's say, let's try to discuss about TTL, time to live, right? TTL stands for time to live. So that is time to live. Let's say I have web01.my.com, right? Now this web01 is actually pointing to an IP address. Let's say tomorrow I want to decide that I don't want to point this web01 to my server, but what I actually want to do is point web01 to a different IP. Let's say I want to point web01 to this IP. This IP, that is 10.18.1.20. So what happens over here is, so let me first do a curl web01.my.com. This is actually giving me this, right? So what I'm going to do is I'm going to edit this record, and here I am going to change the IP address, and I'm going to click on save. So DNS is saved. Now if I point to this, right, you will see that for a very long time I'm still going to be redirected to my old server or the old IP address, if you're getting it, right? Because the actual actual IP that I'm now pointing is that of test.my.com, right? So that means I should be getting a hello page, but I'm not getting a hello page, but I'm getting this. This is primarily because of the TTL value that we have set. The TTL value that you have set is 300 seconds. 300 seconds converts to 5 minutes, right? So the DNS is only going to be flushed, right, or reset on your device after 5 minutes. So if you try to access this same what web01.my.com, you will be getting the actual IP address after 5 minutes because the TTL has been set to this, right? So this is the reason why before a change, right? If especially if it's a DNS change, right? We change the TTL value to, let's say, 10 or 20 seconds, and make sure that the TTL value has been updated. And this is actually done a day before the activity, or at least a day before the activity, because you have to be very sure that the DNS is functioning, right? That way, what would happen is you would be getting a lot of leeway with the DNS entries. So this is what is happening. So this is TTL, right? Now, did I pause for 5 minutes? No. Right. So this is still working. So that's why you make sure that the TTL value is set to a proper thing. Right. So that's very important. Now let's actually come to the heart of Route 53. Now DNS is something which is provided by everyone. Right? So there are many providers that would give you DNS functionality. But what makes AWS a bit special for its services is the routing policies that AWS has. What is a routing policy? A routing policy is a way that you could tell AWS to choose how Route 53, the DNS traffic should be routed uh, to your IP addresses. A simple routing policy means that it would provide normal DNS functionality, right? So that is name to IP address resolution, and depending upon the IP address, the packet should go to that server, right? So that's basically a simple DNS functionality that is provided. When it comes to weighted records, right, it lets you specify which portion of the traffic should be sent to each source. Let's say, let's take an example or a scenario wherein you're testing out some features, right? Let's say you're testing out how your website functions on some servers, right? So instead of using a load balancer and stuff, what you did is you created two EC2 instances, and then you are playing with the DNS, right? So that you could do your stuff. So what you define is, let's say for EC2 instance 1, EC2 instance 2, You say that EC2 instance 1 should get 50% of all the traffic, and EC2 instance 2 should get 50% of all the traffic. So very soon this is happening, and what happens is, let's say you increase the EC2 instance 2 to a better class or a higher EC2 instance. So now this EC2 instance is a bigger size, right? And obviously this should hold more traffic. So what you decide is 75% of the traffic should come to the second instance, and only 25% should go to the first instance. That is possible. So what you can do is weit.my.com, right? So what I'll say is it should go to IP address number 129. I would say that let's keep the weights, right? So here you could define the weights from 0 to 255. So what I say is 175% of the weight should come to this traffic. So that is weight. That is W129 is what it's just a name, nothing else. You could give anything to it. So that has been cleared. So let me actually show you. That is weight.my has been created, right? Weight.my has been created. I'll create another one that is the same name. This time I'm going to give the second IP address, which is no, this one, right? I provide a second IP address, which is this one, and again I'm going to select weighted, and this time I'm going to give out of 75, so let's say I say 50, and I'm going to call it as W97, right? And that's it. So now if you see, did it create? No, yes, maybe. Make a record. Whatever. I didn't provide a value. How is it possible? Okay. That's it. Add a record. Create a record. I accidentally click on add another record, right? So here, if you see now the same IP address, the same DNS name, that is wait.my.com, is actually pointing to two servers. Now, what AWS is going to do is out of 255 requests that are coming in, right? 175 would go to this, 50 will go to this. Right? So that's how it is going to operate for us. Make sense, right? So that's one type of record. Then there is something called as geolocation based routing policy. What happens with geolocation is depending upon where your users are, the users can be in a continent or a country, right? Depending upon where your users are, you can route your traffic to those particular IP addresses. Let's say you say that my users coming from India or Asia should go to the data center in India. And my users who are coming from Europe should go to the data centers in Europe for the IP address of Europe. My users were coming from US, South America, Canada, and all those regions should go to the US, right? And maybe for the extreme east, that is Japan, Australia, New Zealand, and stuff, we have another region in Tokyo, and we want to route the traffic over there, right? So this is how you can actually route certain people depending upon their geolocation to certain places, right? So that is how it can be done. We have also something called as latency based routing. So again, it would be the same latency.my.com one IP, latency.1.my.com another IP address. So there will be two records. So what would happen is wherever the latency is less, what is latency? Latency is nothing but the amount of time it takes for the response to be received, right? So latency in simple terms, I'm a user requesting our website from the access. So this takes some amount of time, t seconds, right? So this t seconds, it could be milliseconds, it could be microseconds, it could be nanoseconds. It's not always mandatory that it should be in seconds, right? So it could be anything. Let's say it is 10 milliseconds, milliseconds. Now this 10 milliseconds is the latency. If you have two servers, it's these two, or let's say three servers. So what DNS is going to see is whichever is providing the least latency, right? Traffic would be going to that. Now you would be wondering if, let's say, this server always provides with 9 milliseconds of latency and this provides with 10 milliseconds and this provides with 10 milliseconds of latency. Is it that every time the DNS will only be routed to this server? The answer is again a no. Right? DNS would be distributed, but what AWS is going to do is, let's say, for some reason, this on this server, right, the latency goes to 300 milliseconds or something, like 300 milliseconds of latency. So what AWS is going to do is DNS is going to make sure that for some time this server is not bombarded with requests because already the latency is high. Right. In the meantime, the engineering teams, if they receive an alert, can go and fix it. So that's how we operate on latency based things. We have something called as failover. What happens in the failover is, so there's also a health check that you have to create for a failover based setup. What you can do is, again, you could have test my.com pointing to two IP addresses. But what would happen is one of the IP address would always remain as primary, and the second one will be always a failover, that is a secondary IP address. So let's say one of the server goes down, depending upon the health check, when the server goes down, it will activate routing the request to the second server. Right? So that is a failover based routing policy. Geo proximity is a new one. I'll go with multi answer at the last. So geo proximity is nothing but so geolocation, you actually provide the country or the continent, right? Geo proximity is actually the longitude and latitude coordinates can be provided. Let's say you want to say Antarctica. Is Antarctica in geolocation? I think so. Yeah. It's already there. But in Antarctica, you say that there are many bases. Most of the bases are next to each other. And let's say you don't want to provide the entire Antarctica continent to be access to your this. So you can actually provide a specific location, latitudes and longitudes, and that also might. Multi answer, the last one, very simple. You could provide multiple answers over here. Right? So it's not rocket science. So let's say it is multi.my.com, and you could provide your IP address number one, then you can provide your IP address number two. That's it. So it's a multi-answer thing, and you can create record ID M1. It's totally up to you. Right. The of type DNS or a set of type A cannot be created without multi-value answers must contain exact one source. Like that. So let's read about this. Multiple value. Multiple answer because let you configure route for multiple values such as IP addresses for your web server plus password. Okay. Okay. So let's test that out. They complain that it should be one, so I'll go with one. I create the one that is multi, multi, and we are going to keep the DNS. Uh, which DNS is the first one having? Is it 129 or 97? Multi is having 97, so this one should have 98, and I want to keep it as multi. There is just multi value, and I call it as M2. I create the record. Now, if I do an NS lookup for this guy, I lost. So let's first see if this is giving the right thing. It should give hello, right? It's giving the right thing. Earlier it was giving the old one. If I do an NS lookup for multi.com, yeah, so it's giving me multiple records. Now it is up to your server to choose on which one it wants to go. Right? it's not AWS who is going to decide on which IP address this person will be going. Multi-record, because it's having multiple IP addresses, it's now up to my server which IP address I'm going to select to connect, right? So let's do this. Multi.com, give me this, give me this, give me this, only giving me this, only giving me this, only giving me this. Why? Because the TTL that I have set is again 300 seconds. For this kind of a situation, maybe the TTL should be 2 seconds or 3 seconds. That's when we will be able to test it out properly, right? Definitely encourage you to test that out. Make the TTL as 2 seconds and then see, but then doing a curl, where actually your requests are going. Is it going to the only to one server, or is it going to multiple places, right? So that is something that we would have to see where it is going. Over and all, this is Route 53, right? We also tested it with some examples that was good. Now, again, Route 53 is not that cheap, right? So make sure that you're destroying everything that you created. So how do I delete all the records? Very simple. You just click on delete records, and that's it. Select delete, and these records will be deleted. Now, why didn't I select these records to be deleted? You will not be able to select, or you will not be able to delete these records. These are default ones that get created when the host zone itself is created. So that's why you will not be able to do it, right? And now you can also delete your hosted zone itself. Make sure that you're doing that. Don't leave hosted zones dangling unnecessary AWS bill, which you can avoid paying, right? It's not going to take a lot of time to create it and start using it. So make sure that we're getting rid of this. I will also remember that I created two EC2 instances, so I'll also get rid of them. Boom. Okay, so that was about Route 53. Okay, if there are no questions, then let's actually see what's the next topic that can be discussed afterwards. So, Route 53 is something that we have discussed, SES is something that we discussed. The next class, which is tomorrow, would be the last class of AWS. We would be discussing IAM and AWS CLI combined. So we would be discussing this along with the S3 example. So if you remember, I have not deleted our S3 buckets. Or did I delete the S3 buckets? I think I deleted the S3 buckets, right? So yeah, I deleted the S3 bucket. So tomorrow we would actually be creating an S3 bucket and then create some IAM users roles, look at the theory of it, and then try to see how it goes, right? And for the next class, we starting Terraform.